it includes, starts at the mouth, so here's the tongue. This right here is the pharyngeal tonsil. We talked about tonsils. It's also known as the adenoid. We can't see on this model the palatines too well, but there's one palatine tonsil here, there's one on the other side, and there's two lingual tonsils. And again, we'll see them better in another head preparation.
I'm sorry, I thought it was blocking her this way.
Yes, but just go.
Okay.
This is the epiglottis. When we swallow, the epiglottis closes over the glottis, which is the opening in the trachea, and so the food can go down in the esophagus. So here's the esophagus. Here's the stomach. At the lower portion of the esophagus, at the beginning of the stomach, this is called the cardiac region of the stomach, and there is a weak sphincter here we call the cardiac sphincter, also known as the lower esophageal sphincter. Here's the stomach. These ridges in here are called rugae. We'll next week look at another stomach and look at other parts of the stomach. But this is the cardiac region, this is the fundic region, this is the body, and this is the pyloric region. Indeed, we get down to this end, we have a very strong sphincter called the pyloric sphincter. This sphincter here, is, as I said before, is pretty weak. A lot of people have problems with it. Acidic contents regurgitating up into the esophagus can cause esophageal erosion, put you at high risk for lower esophageal cancer. At the very least, you can get GERD, gastroesophageal reflux disease. Pyloric sphincter, when it opens, foodstuffs move into the first 6 inches of the small intestine, known as the duodenum or duodenum. The duodenum receives a little green thing there, which is the common bile duct. It's coming from this. This is our gallbladder, and here's the cystic duct. The common bile duct is starting right here from a confluence of the common hepatic duct, which is made up from the right and left hepatic ducts. So the common hepatic duct and the cystic duct make up the common bile duct, and that enters right over here. Actually, it enters right down over here. This is called the pancreatic duct, comes up here and down over here, and the common bile duct joins with the pancreatic duct over here and opens into the duodenum at something called the major duodenal papilla. Again, we'll look at another model that shows it better later on. This is the accessory pancreatic duct, and it opens into the duodenum at what we call the minor duodenal papilla. In the duodenum is where we mix all the digestive enzymes from the pancreas. Pancreas is, of course, mostly digestive, as we know, and so we mixing the digestive enzymes in here. We're adding bicarbonate and stuff here to neutralize the acidity from the stomach, and then we end the duodenum with a turn that enters the jejunum. The jejunum is the next part of the small intestine and goes all around in there, and then we halfway through, or not even halfway through, we turn into the third part of the small intestine we call the ileum. So we have the jejunum, we have the duodenum, the jejunum, and then the ileum. The ileum ends right over here, comes in right here and forms a valve right here, or joins a valve. This is called the ileocecal valve, and this allows the contents of the ileum to enter the cecum. This is the end of the ascending colon. So here's the cecum, and here's the ileocecal valve, and here's the vermiform appendix. Vermiform means worm-like. Jutting off, we already said tonight that this is full of lymphatic tissue, but this is a problem with most humans. This is the ascending limb of the colon. It's coming up this way. This model doesn't have the transverse. The bend over here is called the hepatic flexure because the liver sits right over here. So the hepatic flexure is a really tight bend over here. A lot of people have an extra large transverse colon. We call it a redundant colon, and makes this curve pretty tight and problematic when we do colonoscopies. The bend over here is known as the splenic flexure because the spleen's on this side. This is, of course, the descending colon. Again, another model will show us the sigmoid colon and dumping into the rectum where we collect the feces. The primary function, of course, of the colon is just to reabsorb all the water we put in here. And, of course, then we go to the anus. This is skeletal muscle here, the external anal, or the anal sphincter here is skeletal muscle. This has to be voluntary. This connective tissue that we see going down the middle of the colon is called the tinea coli. And these pouches here are called haustra, H-A-U-S-T-R-A. If these haustra start bulging out, and they normally do with age, we call those diverticula. And if the diverticula become inflamed, we call it diverticulitis. Okay, well, I'll start by looking at this. This model, since I have it out here, this is a cross-section for one of the small intestinal pieces. And we are...
You need it.
Thank you. Appreciate it.
Hands. I feel like blocking everything you're touching. Just FYI. Continue.
Who cares? Anyway, the intestinal wall, actually the wall of the entire gastrointestinal tract, is relatively similar in basic structure. We'll go through that in a lecture. But essentially, most significant down here, we see the... Out of my face, man. You gotta take it out of my face.
Oh, it still is? Okay, it's out.
We have two layers of muscle here. One is called the circular muscles and the longitudinal muscles, and they're responsible for mixing and moving stuff throughout the tube here. The stomach has a third layer called the oblique layer, which helps it churn. So this is responsible for peristalsis and some kind of mixing movements we call segmentations. The other mixing movements we see again in the stomach in the third layer. We're going to be talking about a part of the nervous system you probably didn't talk about last semester called the enteric nervous system. Because you should be really doing the somatic, the autonomic, and the enteric. A lot of my colleagues include the enteric under the autonomic, although the autonomic does not control the enteric nervous system. It's got a mind of its own, so to speak. The enteric nervous system has two components. It has a myenteric plexus, which controls the motor activity, and it has something called the submucosal plexus, which controls secretions in the system. These little finger-like projections are called villi. Here's a lacteal that we talked about of the lymphatic system. This is one of Peyer's patches. I told you that our lymphoid tissue that's found in the small intestine, the ileum, this bit particularly. And over on the side here, why do I make you see that a plaster? You see one of the intestinal glands over here. So here's the intestinal gland. This is a Peyer's patch. The villi, or villus, villi is plural, a lacteal of the lymphatic system. This yellow stuff here actually represents the nervous tissue of the enteric nervous system. And if I said what part of the enteric nervous system is over here, you just say the myenteric plexus. And over here, of course, would be the submucosal plexus. All right, well, I'll keep you busy for a couple minutes.
Which one's the enteric plexus? I'm sorry.
No, I never said it was an enteric plexus.
You said that. Mesenteric.
No?
No, sorry, not mesenteric. All right. I see.
No? Myenteric.
Myenteric, sorry.
I
know it was some
myenteric versus the muscle.
I know it was some N.
There you go. And then the other one would be the submucosal plexus. The submucosal plexus would be the submucosal. We'll go through this again.
Okay.
And it controls secretions. The myenteric controls motor activity. That's movement, churning, mixing. Okay?
Thank you.
Okie doke. So we'll add more next week.
You still have to add more?
Excuse me, this is
I'm
like
sorry.
this is like the,
This is our
this is like
table.
the overview of the world map.
Cool.
You have to study. We got boxes actually that have all the digestive models.